Biomechanics is the application of mechanics to the human body in sporting implements and studies forces acting on the body. Kinematics is the branch of mechanics that involves the action of motion and movement, such as the study of motion on an object or a body. Some types of motion are linear motion, which is movement in a straight line, curvilinear motion, which is movement in a curve, angular or rotational movement, which is movement around an axis, and general motion, which is linear and angular motion together. An example of linear motion in basketball is someone's torso when they are running, because it stays straight and doesn't rotate at all. An example of angular motion would be the legs movement while a basketballer is running, as they are moving at angles and rotating around the hip joint. Running as a whole would be general motion, as it includes both angular and linear motion. Kinetics is another branch of mechanics that involves the action of forces involved in the movement of the body or an object. For example, in basketball, the movement of passing the basketball relies on the forces that are acted against it to make it move. The method of creating a numerical model involves many different aspects. We use a numerical model when we collect the data for the vertical jump. Before the test, a PAR-Q needs to be completed to ensure that the participant can participate safely. This involves asking them about their previous and current health. For example, have you ever suffered or do you suffer from high blood pressure? This allows the researcher to keep an eye on any signs or symptoms from the conditions, because they must make sure that they are safe during the jump. After this has been completed, the participants should get ready for the test by completing a warm-up, reducing the risk that they will injure themselves. This also helps to standardise the test and improve reliability, because the performers will all prepare for the test in the same way. If one performer did a warm-up while another didn't, it would give them an advantage. Next, they need to be told the protocols of the test, so they know what they are doing to help further standardise it. When the participant is standing on the force plates, they need to be calibrated so their weight isn't included in the force. This needs to be done for every participant, otherwise their results would be affected by the force plates not being set at 0 at the start. As we use 2 force plates so that they can fit their jump on, we need to make sure that they are both calibrated the same. Before the jump, we had to measure the angle of the leg bend to 90 degrees using a gynometer, so they know how far they should bend before the jump. Then they could stand on the force plate and jump, landing back on it. To collect the data, we filmed the participants' jump. For this to work, we needed to ensure that the camera was prepped properly. The tilt, roll and pan of the camera should be considered. The tilt refers to whether the camera is higher on one side, so for a better film it needs to be completely straight. The roll of the camera is whether the camera is facing straight and not pointing upwards or downwards. To ensure that there is no tilt in the camera needs to be level with the participant so it can film the whole jump without having to move up or down. The pan makes sure that the whole jump can fit into the picture. A way to make sure that the jump is filmed correctly is triangulation, which helps to make the camera film the jump from the right perspective, which is perpendicular to the performer. This is done using Pythagoras' theory using triangles. As you can see from the picture, the length of the triangle can be measured to make sure that the camera is at a right angle to the performer. Something else that needs to be considered in the camera is the shutter speed or the frame rate. This is important because it controls the speed that the camera has to take photos. If it is too slow, then the jump won't be captured, but if it is too fast, then the film may be too dark, so it is important to find the most suitable shutter speed. If the camera isn't set up properly, this can lead to problems when the data is collected, for example, perspective error. If the camera isn't in the right place, it can lead to something looking different than it actually is. For example, if the camera was filming the jump not from a perpendicular angle, then the angle of the participant's jump may look like it was not 90 degrees, even though it was. To collect the data, we use 2D imaging using the camera. However, the accuracy could be improved by using 3D images such as Vicon. This gives a 3D image of the performer and their jump, so it can be seen from many different angles. However, there are problems with using a numerical model, as it is subjective. You have to measure the separate stages of the jump on the computer by hand, so it relies on where you think that the stages of the jump start and end. This means that different people may measure the stages differently and for different participants, so it lacks reliability. Furthermore, the process of collecting the data onto the computer takes a very long time, as you need to input all the scores into a spreadsheet. So although it may be good if you're collecting data from just one person, if it's for lots of people or a group, then it may not be suitable because it takes too long. There are also issues with validity, as this method lacks ecological validity because jumping on the force plates is different to jumping in a game situation. For example, in basketball, the players often run into their jumps. However, on the force plate, the jump is done from standing. This means that the results can't be generalised to the game. It is also hard to measure the angle of the leg bend and ensure the participant only bends to this angle when jumping. However, we could have improved this if we had used something to stop the participant from bending lower. A force acts upon an object or the body in order to create motion and can either be a push or a pull force. There are 5 effects that a force can have, and these are the change the shape of the object, causing something to start moving, causing something to stop moving, to accelerate an object or to de-accelerate it. For example, in basketball, these effects of forces can be seen during the passing of the ball. When the ball is thrown, force is applied to it, which will cause it to temporarily change shape. As the force is applied, the ball starts to move as it pushes away from the player, causing it to start moving, and after this it will start to accelerate as it increases in speed and starts moving towards the next player. When the player goes to catch the ball, it will de-accelerate in speed because the force is being applied by the player until it will eventually stop moving as a result of the force being applied to it. Some types of forces are a direct and eccentric force. A direct force is when the force is applied directly through the object's centre of mass, which would cause it to go straight. For example, if the basketball is thrown with the force applied directly to the centre of mass, it will go in a straight line without any spin. An eccentric force is when the force is applied to the outside of the object's centre of mass, for example, on the outside of the basketball, which will cause the ball to spin as it is thrown, affecting its movement. Newton's first law of motion is called inertia. This is the rule that something will stay at a constant motion until there is an external force acted upon it. For example, something that is moving at a constant velocity will carry on moving until a force causes it to stop, or something will continue to be still until a force causes it to start moving. This can be explained through balanced forces. When the forces that push on both sides are equal, then there is a net force of 0 and no acceleration, so there will be no change in motion. For motion to change, the forces acting upon something must be imbalanced, otherwise motion will remain the same. In basketball, an example of inertia would be when the ball is thrown. It goes at a constant velocity until someone catches it, which is the force that causes it to stop. When someone is holding the ball, there is no motion. However, when they push on the ball to throw, this is the force that is acting upon it, causing it to move. Once it is in the air, it will go at a constant motion because the forces acting on it are balanced, until it is caught when the forces become unbalanced again, causing its motion to change. Newton's second law of motion is called acceleration, which refers to a change in motion of something, for example, an increase in velocity. When forces act upon something unbalanced, then this will cause acceleration. An object's acceleration is directly proportional to the net force acted upon it, and it will move in the same direction as the net force. So if there is a higher net force, then there will be more acceleration. Acceleration is inversely proportional to the mass of an object. So the higher the mass of the object, then the less acceleration there will be, or it will need to have a higher net force to accelerate. For example, in basketball, when acceleration is used is when the player throws a ball and it will increase in acceleration. The mass of a basketball is roughly 0.625 kilograms, and this doesn't change, so the acceleration of the ball would be determined by however much force the player applies to the ball, divided by its mass. Newton's third law is the action-reaction law, which is that to every reaction there is an equal and opposite reaction. For example, in basketball, when a player is shooting, their action would be the player pushing force on the ball, and the reaction to this would be the ball being released from the hands and going towards the hoop. Impulse is another way to describe a force and is concerned with the amount of force applied to an object and the length of time that this force is applied to it. A consequence of impulse is a change in momentum of the object. Impulse is calculated by force times time, and if either one of these increases, there will be a greater impulse. For example, if a basketballer applies 10 newtons of force to a basketball for 1 second, then the impulse would be 10 newtons per second. However, if they applied more force to the basketball, or applied the force for a greater amount of time, then the impulse would also be greater, which would cause the basketball to be thrown further. Momentum is the amount of motion that a moving object has, and once it is in motion, it tends to stay in motion. It is the product of an object's mass and velocity. A change in momentum is measured by mass times the velocity and is measured in kilograms per meters per second. If something has a higher mass, then the momentum will be higher. However, this tends not to change, so to manipulate the momentum, the velocity would need to be increased. For example, a basketballer may be running at 5 meters per second, and if their mass is 80 kilograms, then their momentum would be 400 kilograms per meters per second. As the performer's mass can't change, a change in momentum will be because either acceleration or deceleration, thus changing the velocity and having an impact on the performer's momentum. Stability is important as it helps someone stay upright and relates to how difficult it is to disturb the body from a balanced position. If someone's centre of mass moves outside of the base of support, this will cause someone to become unstable. Stability is often used in basketball during the box-out rebound because the player needs to remain stable when blocking another player from getting the ball's rebound, and to increase stability, they will widen their base of support and lower their centre of mass. Centre of mass is the point at which the body is balanced in all directions and tends to be located around the belly button. However, the centre of mass changes in different positions. If someone's mass is distributed differently, for example holding their hands above their head, as if going to shoot a basketball, then the centre of mass will change. In this example, the centre of mass will be higher because they will have more mass higher up above their head. By lowering your centre of mass, this increases stability. So during a box-out rebound, the player will bend their knees to lower their centre of mass. Therefore, if they are pushed by an opponent, they are less likely to fall over. Someone's base of support directly correlates to the stability. For example, to be more stable, their line of gravity needs to be within their base of support. So the wider the base of support, the more likely that they will be able to keep this line within it and remain stable. For example, in the box-out and rebound example, the player will keep their legs wide in order to have a bigger base of support and increase their stability. Stability can be further increased by having 3 points of contact, as this increases the base of support. However, this isn't used in basketball. It is used in other sports such as a headstand in gymnastics because there are 3 points of contact, the head and 2 hands, making it more stable than a handstand where there are only 2 points of contact.